Okay, good morning, students. Welcome to today's lecture. So, in our last lecture, we had started with the problems on the viscosity. Okay, and we had seen what is Newton's law of viscosity, and we had solved problems on it. So, in today's lecture, we will solve one problem and we will see the remaining properties. Two large plane surfaces are 2.4 centimeter apart. The space between the surfaces is filled with glycerin. What force is required to drag a very thin plate of surface area 0.5 square meter between two large plane surfaces at a speed of 0.6 meter per second? If case number 1, the thin plate is in the middle of the two plane surfaces. Case 2, the thin plate is at a distance of 0.8 centimeter is at a distance of 0.8 centimeter from one of the plane surfaces. Take dynamic viscosity of glycerin is equal to 8.1 into 10 power minus 1 Newton second per meter square. Okay, so what is given in this problem? In this case, there are two large plates. Okay, 1 minute. In this case, there are two large plane surfaces. So this is two large plane surfaces. They are at a distance of 2.4 centimeter apart. Okay, so distance between them y, that is 2.4 centimeter. Then the space between the surfaces is filled with glycerin. So there is a fluid which is glycerin. Now, what is the force required to drag? Drag means suppose you want to move this plate. Okay, so there will be some resisting force to this motion. So that force is nothing but drag force. So drag force is nothing but opposing force to motion. Okay, in the fluid. So that force is drag force. So what is this drag force required to move the thin plate of surface area? Okay, so its surface area is given as, that is 0.5 meter square or square meter. Okay, at a speed of, okay, so velocity is given. So velocity is u equals to 0.6 meter per second. Okay, now here there are two cases, the location of this plate. In first case, it is at the center, that means 1.2 centimeter from bottom and 1.2 centimeter from the top. And in second case, it is 0.8 centimeter from one of the plane surface. Okay, so in both the case, the distance dy is different. Okay, so we'll solve this problem for two different cases. Okay, and also the viscosity is 8.1 into 10 power minus 1 Newton second per meter square. This is a given condition. You can see, we will see our first case when the plate is at the middle of the two plane surface. So when it is at the middle of the two plane surface and the distance between them is 2.4, so at the middle from bottom the distance y1, it is 1.2 centimeter, and from the top the distance y2, that is also 1.2 centimeter. Okay, so first of all, in our case one, when the plate is at the middle of the two plane, we will say let F1. Now see, in this case, there are two cases. In first case, there is one stationary plate at the bottom and moving plate at the top. Okay, so on this surface, there is one drag force F1, which will be acting on lower surface. Okay, similarly, on top side, there is one fixed plate at the top, and on this plate, it is a moving plate. So here also, there will be some other force F2. Okay, so this F2 is the drag force due to fluid between top plate and given plate, and F1 is nothing but the drag force due to the resistance, okay, or due to viscosity between the bottom plate and given plate. Okay, so we'll say let F1, it is a shear force on upper side, and F2 is the shear force on lower side of the thin plate. Okay, so the total force F is nothing but F1 plus F2. Okay, so first of all we will calculate F1, then we will calculate F2, and then we will add them in order to get the total force F. Okay, so let at the top, okay, we had defined F1 on upper side, so we will say this is F1. On the bottom side it is F2. This is Y2, this is Y1. Okay, so let whatever the shear stress on upper side is tau1. Okay, so we will apply the Newton's law of viscosity in between the fluid of top plate and thin plate. Okay, so in this case dy1, so this dy1 is nothing but y1 minus 0, so it is 1.2 centimeter. Okay, similarly du1, so du1 is nothing but u minus 0, so u is 0.6 minus 0, so it is 0.6 meter per second. Okay, so we will apply this in our Newton's law of viscosity. So tau1 equals to mu into du by dy for upper side, that means 1. Okay, that will be mu is 8.1 into 10 power minus 1 du is nothing but change in velocity between thin plate and upper plate, so it is u minus 0, so 0.6 minus 0, so it is 0.6 meter per second. Similarly dy1, it is nothing but the distance between the upper plate and thin plate, so it is 1.2 centimeter. Okay, so it is 0.012 meter, 1.2 into 10 power minus 2, so it is 0.012 meter. Okay, now in this case nothing about the thickness of the plate is given, so you can neglect the thickness of the plate. Okay, so we will put this value, so it is 8.1, okay, into 10 power minus 1 into du1 is 0.6 divided by dy1 is 0.1. Okay, so it comes out to be 14.5 Newton per meter square. Okay, now once tau1 is known to us, we can calculate F1. So we know tau1 is nothing but shear force upon area. Okay, so shear force F1 is nothing but shear stress into area. You just multiply 40.5 with 0.5 meter square. So it will be, yes, 20.25 Newton. Okay, so F1 is 20.25 Newton. Now once F1 is known to us, now see, in this case, in our case 1, this was plate and fixed plate, and this was moving plate. Okay, this Y1 is 1.2 and y2 is also 1.2. That means y1 is equal to y2. Similarly, du1 is nothing but this is fixed plate, so velocity is 0. This is moving plate, so velocity is 0.6 meter per second. So du1 was 0.6 meter per second. Okay. Similarly, du2 is also 0.6 meter per second. Okay, so du1 du2 are same, y1 and y2, or dy1 or dy2 are same, and also mu is same. Okay, mu1 is equal to mu2 in both the case, fluid is glistening. So basically this f1 is equal to f2. Okay, so tau2 भी आप calculate करोगे, f2 भी calculate करोगे, so same formula, tau2 equals to mu du by dy2, so it is 8.1 into 10 power minus 1 into du2, again 0.6, dy2 is again 0.012, so on solving it is again 40.5 Newton per meter square, and f2 is again tau2 into area, so 40 into 0.5, so 20.25. Okay, so F1 and F2 are known to us. So total F is nothing but F1 plus F2. So 20.25 plus 20.25. So it is 40.5. Okay. Final answer is 40.5. Yes. In case 1, our total force required to move the plate or total drag force is 40.5 Newton. Okay. After that, case 2. Now in case 2, one of the thin plate is at a surface of 0.8 centimeter. Okay, that means in this case, this is our fixed plate, top fixed plate, this is our bottom fixed plate. Okay, and this is our moving plate. So its distance from one of the plate. Okay, we will say suppose lower plate y1. So y1 is 0.8 centimeter, and total distance is 2.5 centimeter. 2.4 centimeter. Okay, so basically in this case y2 is y minus y1, y minus y1. Okay, so it is 2.4 minus 0.8, so 1.6 centimeter. Okay, so in case 2 y1 is not equals to y2. Okay, so in case 2 y1 is not equals to y2, so therefore f1 and f2 will be different. Okay, so remember the second case, in second case f1 and f2 will be different. Okay, so we'll say let the thin plate is at distance of 0.8 centimeter from lower plate. Okay, so this is our final figure. So you can see from lower plate the thin plate is at a distance of 0.8 centimeter, and from the top plate it is at a distance of 1.6 centimeter. Then the shear force on upper side of the thin plate. First of all, we will calculate on the upper side. So we know tau 1, okay, tau 1 or F1 is nothing but tau 1 into A. Now this tau 1 is nothing but mu into du1 by dy1. Okay. Now in this case, mu is again, mu is same 8.1 into 10 power minus 1 du1. Du1 is again 0.6. Okay. This plate is moving with 0.6 centimeter per second and upper plate is stationary. So du1 is 0.6 meter per second and dy1 is now 1.6 centimeter, so it is 1.6 into 10 power minus 2 or 0.016 into area. So area is 0.5. Okay, so it comes out to be 15.18 Newton. Now we will calculate F2. Now for F2, now F2 will be the force that will be required to move the plate from lower plate. Okay, so that F2 is tau 2 into area. So that tau 2 is nothing but mu into dy2 du2 by dy2. So du2 is again same 0.6 meter per second and dy2 is nothing but now it is 0.8 centimeter. Okay, so it will be 0.8 into 10 power minus 2. So put all the values. So mu is 8.1 into 10 power minus 1 into du is 0.6 divided by dy2 is 0.8 into 10 power minus 2 into area is 0.5. It comes out to be 30.36 or 30.375 Newton. Okay, both the answers are correct. After that, next is total F. So total F is nothing but F1 plus F2. Okay, so you can add them. So 15.18 plus 30.36 or 30.375, whatever both the answers are correct. Okay, so final answer is 45.54 Newton. Just add them. Okay, so you can see when the plate is at the center, the force required is only 40.5 Newton per Newton. Okay, but when it is at a distance of 0.8 from one of the side, so the force required is 45.54 Newton.